Hello guys, welcome to our mobile computing video series. Today we dive into the global mobile satellite system GMSS, a critical part of extending the wireless communication to remote and inaccessible areas around the globe. In this session we will take a closer look at two major satellite systems, Iridium and Global Star network. These systems provide global coverage using satellite constellations in the orbit, enabling the communication even in areas with no terrestrial network infrastructure. We will discuss or explore each system's architecture, working principle, and real world application through detailed case study. So let's explore how space-based communication bridges the digital divide. Grab your notes and let's begin our journey. At first, Iridium system. Overview and case study. The Iridium system is a satellite communication network designed to provide the global voice and data services using a constellation of low Earth orbit satellite (LEO). Launched in late 1990s, Iridium consists of 66 active satellites orbiting at 780 km at altitude, arranged in 6 orbital planes. What sets Iridium apart is its ability to offer true global coverage, including polar regions. Sometimes most other satellite systems cannot achieve. Communication is established by routing calls through multiple satellites in space using inter-satellite links until the signal reaches the destination or a ground station, you can say. The Iridium system uses the TDMA and FDMA technology and operate in a L-band frequency, ensuring the resistance to weather-related interference. Although the original project faced financial difficulties, it was received and is now widely used by military forces, aviation sectors, and emergency responders. Its capability to deliver communication is in disaster zones or during power outage makes it indispensable in critical scenarios. So, the Iridium system showcases how a well-designed satellite network can support reliable mobile communication across the globe. Global Star system. Global Star is another prominent satellite communication system also operating in low Earth orbit, but with a slightly different architecture than Iridium. Instead of using inter-satellite links, Global Star satellite act more like repeaters, relaying signals directly from user terminal to terrestrial gateway. It uses 48 satellites in orbit and operates in L and S band both, which are suitable for mobile and voice services. Because it relies on ground-based gateways for signal routing, Global Star provide strong service in region with good gateway coverage but limited or no service in remote ocean or polar areas. Despite this limitation, Global Star often excellent performance in North and South America, Europe, and parts of Asia. It is often used in industries such as forestry, oil and gas, emergency response, and remote scientific research. The system support services like voice calling, SMS, GPS tracking, and low bandwidth data transmission. A key benefit of Global Star is low latency and reduced power consumption in user devices compared to systems using inter-satellite routing. Studying Global Star helps us to understand a more Earth-dependent but still highly effective approach to global satellite communication. So that's wrap up our session on global mobile satellite system. Today we explored how satellite network like Iridium and Global Star provide mobile communication in the areas far beyond the earth of traditional cellular network. These systems are vital in emergency services, remote exploration, and defense communication. As we move forward into the increasingly connected environment, satellite systems continue to play a critical role. So in our next and final video, we will look into the wireless enterprise network and technologies like Bluetooth and virtual network. So if you enjoyed this session, be sure to like, share, and subscribe to stay updated on the full mobile computing series. So see you in the next class.